A coronal mass ejection struck Earth's magnetosphere during the overnight hours of May 19th into May 20th, 2026, a glancing blow, measured and confirmed, delivering solar wind speeds recorded by the UK Met Office at strong levels between 600 and 730 km per second, and for a window of hours this planet's magnetic field registered conditions that brought the KP index to the threshold of what NOAA classifies as geomagnetically active, precisely the kind of event that, with 1 degree of difference in magnetic orientation, 1 degree more southward tilt in the interplanetary magnetic field embedded in that arriving plasma, does not end with aurora alerts and unsettled conditions. It ends with the lights going out. If you rely on this channel for science that is grounded in verified data and explained with honesty, subscribing ensures that none of this reaches you late. This work depends on the audience that values it. Every figure in this script was drawn from official scientific and governmental sources. NOAA's Space Weather Prediction Center, the UK Met Office, NASA's Goddard Space Flight Center, Space Weather Live, COM, Earthsky, the Smithsonian, and peer-reviewed research published in journals including PLOS One and Space Weather, but official sources are not infallible, and neither is the human process of reading them before any decision is made, whether personal, professional, or otherwise. Verify independently through the official channels. The sources are listed. The data is public. The responsibility to check belongs to all of us, but that is not even the complete picture. Because what arrived at Earth in the early hours of May 20th, 2026 was not just a single traveling mass of magnetized solar plasma. What the official monitoring data from the Met Office, from Earthsky's solar astrophysicists, from NOAA's GOES-19 satellite imagery confirms is something that should command full attention. A complex, multi-source event. A coronal mass ejection that was knotty and irregular in structure, as described by analysts watching the SEEK or 1 coronagraph aboard NOAA's GOES-19 satellite. A blast launched from the Sun on Saturday, May 17th, analysts tracked it across interplanetary space. It arrived on schedule as they predicted, and it did something that the data shows is deeply significant, not because of the damage it caused this time, but because of the precision with which it demonstrated exactly how this system works. How a glancing blow that did not quite trigger a full geomagnetic storm can, under slightly different conditions of magnetic orientation, become the event that brings down the grid. The NOAA Space Weather Prediction Center measures geomagnetic disturbance on the KP scale, a planetary index running from 0 to 9, where 0 is absolute, calm, and 9 is extreme. The index is derived every 3 hours from 8 ground-based magnetometer stations distributed across the globe: Sitka in Alaska, Minuk and Ottawa in Canada, Fredericksburg in Virginia, Heartland in the United Kingdom, Wingstand Nijmegen in Germany, and Canberra in Australia. These are the instruments maintained by the U.S. Geological Survey, Natural Resources Canada, the British Geological Survey, the German Research Centre for Geosciences, and Geoscience Australia, whose readings become the official planetary index. When the index was projected to reach 567 for this event, a figure confirmed in the NASA Kimkdonki database in connection with the January 2026 G4 storm that recorded KP values reaching 867. That is not a marginal number. KP5 is the minimum threshold for a geomagnetic storm. It is the point at which NOAA issues storm watches. And what the data from the Met Office showed for the days immediately preceding May 20th was solar wind moving at 600 to 730 km per second, wind not from a solar flare but from a coronal hole, a dark region on the Sun's surface where the corona is cooler and thinner and the magnetic field lines open outward into space like the nozzle of a jet, releasing a continuous high-speed stream of particles that can drive geomagnetic activity for days, 630 km per second. That is the speed of a particle of plasma crossing a distance equal to the circumference of the Earth in less than 1/10 of 1 second. And here is where this account becomes genuinely significant. This storm arrived alongside that coronal hole stream, a compound event, 2 separate drivers combining their effects. The Met Office explicitly noted that geomagnetic activity elevated to G1 and possible G2 conditions through May 19th and 20 was attributable to lingering CME effects combined with elevated solar wind speeds from the coronal hole high-speed stream, 2 drivers, one arriving from a specific solar eruption on May 17th. One, a persistent structural feature of the Sun itself, a coronal hole located at or near the solar equator, the location that NOAA confirms is most likely to produce elevated solar wind speeds at Earth's orbit. These 2 forces did not cancel each other. They combined, and the forecast range from that combination was a KP of 3 to 5 depending on one variable: the magnetic orientation of the arriving plasma upon impact, the southward or northward tilt of the interplanetary magnetic field embedded inside the CME. One direction means a quiet night. The other means the magnetic shield opens. That single variable, the orientation of a magnetic field traveling 150 million kilometers from the Sun to Earth, is the variable that determines whether 120 million people lose power. That is not a hypothetical. That is what the Lloyd's of London risk analysis of the North American electrical grid confirmed in its formal assessment. That is what peer-reviewed research published in PLOS One in 2025 established after examining DOE outage data from 2006 through 2023 against heliospheric parameters from NASA's OmniWeb database. The relationship between geomagnetic storm activity and reported power outages of unknown or unusual origin in the United States is documented. The data is there, the record exists, the system works this way. When a CME or a high-speed coronal hole stream arrives at Earth carrying a southward-oriented interplanetary magnetic field, what physicists call negative B's, it couples directly with Earth's own magnetic field. The magnetosphere opens, solar wind energy pours in. This drives electrical currents in the ionosphere called geomagnetically. Induced currents, or GICS, and those currents do not stay in the upper atmosphere. They flow down through the ground. They travel along any long conductor on the surface: pipelines, railway lines, fiber optic cables, and above all, the high-voltage transmission lines of the power grid. NOAA confirms that GICS can reach 100 amperes along transmission lines during severe storms. 100 amperes flowing through a system designed to carry a different current entirely, saturating the iron cores of the transformers, causing them to overheat, to vibrate at harmonics they were not built to sustain, and in the worst cases, to fail permanently. Transformer failure is not a short outage. These are not circuit breakers that reset. Extra high voltage transformers, the massive units that sit at the heart of the transmission grid, take 12 to 18 months to manufacture. They weigh hundreds of tons. They are custom-built for specific substations. There are no warehouses full of spares. A Carrington-level event occurring today, according to the Lloyd's of London analysis, would inflict economic damages estimated at $2 trillion, with blackouts lasting not hours but weeks to months across continents. What Science Times reported in December 2025 stated clearly, a 12% probability of G5-level storms per decade, not per century, per decade. There is a city of approximately 2 million people in northeastern Canada that knows exactly what this risk looks like at human scale. The city is Montreal. The date is March 13, 1989. At precisely 2:44 in the morning, a coronal mass ejection that had crossed the distance from the Sun to Earth in 31.5 hours struck the planet's magnetic field. The solar active region that produced it, designated NOAA Region 5395, had generated an X-15 class solar flare on March 6. The CME it launched registered a travel speed of 1,320 kilometers per second, faster than the event arriving this week, significantly faster. The KP index during that storm reached 9. The AP index reached 246. The disturbance storm time index plunged to negative 589 nanoteslas. These are the numbers. They are in the official record. At 2:44 am, geomagnetically induced currents found their way into the transmission infrastructure of hydro. Quebec sits on the Canadian Shield, a vast ancient formation of Precambrian igneous rock that is electrically resistant. The currents could not dissipate into the earth as they would elsewhere. They flowed instead into the high-voltage lines, overloading transformers, tripping automatic circuit breakers in a cascade that moved faster than any human operator could respond. The entire Quebec power grid went offline, not a district, not a borough, the entire province, in less than 90 seconds. 6 million people lost electricity. They woke in the dark, in March, in a Quebec winter, with temperatures below freezing and no heat. The blackout lasted 9 hours. In downtown Montreal, millions of people were trapped in elevators, in underground pedestrian tunnels, in darkened office towers. A General Motors plant in Montreal lost 356 cars worth of production, $6 million in 8 hours. A steel company reported $5 million in losses from steel left cooling and hot rolling mills. And that was a G5 storm that struck Canada in 1989, when the grid was smaller, when there were fewer people connected to it, when the infrastructure that now services 120 million people in the northeastern United States and southeastern Canada was a fraction of its current scale. Think about what that means today. Think about what a family in Burlington, Vermont looks like at 2:44 in the morning in the context of an event scaled to the infrastructure of 2026 and not 1989. Burlington has approximately 45,000 residents. Most of them are asleep. They have insulin in refrigerators. They have oxygen concentrators running in bedrooms. They have electric pumping systems moving water and removing waste. They have phones charging that will become useless when the cell towers lose backup power. None of those people know that on the Sun, 8 minutes away at the speed of light, a magnetic field was oriented in the wrong direction for 36 hours. That is the gap between what the data shows and what the people living in its path. Understand, this is not a hypothesis. This is documented in the geological record and in the operational history of every major power utility in the Northern Hemisphere. Dr. David Bottler, head of the Space Weather Group at Natural Resources Canada, called the 1989 Quebec storm the biggest geomagnetic storm of the space age and the archetypal disturbance for understanding how solar activity causes blackouts. Archetype, the template. The event from which all preparation, all circuit breaker recalibrations, all series compensation installations, all real-time GIC monitoring systems derives, and hydro itself acknowledges in its official documentation that the March 13, 1989 blackout was the catalyst for everything they subsequently built: the trip-level recalibration, the alert systems, the operating procedure modifications that require reduced power flow on lines during magnetic storms. All of that came after. All of that was reactive. Now consider what came before 1989 by exactly 130 years. September 1, 1859, an English amateur astronomer named Richard Carrington was sitting in his observatory in Redhill, near London, sketching sunspots through his telescope. He described what happened next as a singular outbreak of light lasting approximately 5 minutes, a white light flare, visible to the naked eye through a filtered instrument, a brightness so intense it interrupted his drawing. 17 hours and 36 minutes later, the estimated transit time of the CME that followed that flare, Earth's magnetic field was struck by what remains, in recorded history, the most intense geomagnetic storm ever measured. The DST index estimates range from -800 to -1,750 nanoteslas, for context. The Quebec storm reached -589. The Carrington event, according to a 2024 study using digital reconstruction of historical magnetograms from Greenwich and Kew observatories, was more severe than previously estimated, more severe. A revised upward assessment of the worst solar event in history. In 1859, the only electrical system of any scale was the telegraph network. What happened to it is documented in the operational records of telegraph offices across North America and Europe. Electrical currents surged through the lines operators received. Electric shocks. Papers caught fire. Some telegraphic equipment continued to operate without being connected to its batteries, powered purely by the geomagnetically induced currents flowing from the Earth itself. The telegraph system of 1859 was what the power grid is in 2026, the only full-scale electrical infrastructure in existence. And it was destroyed, briefly but completely, by a solar event whose energy inflations calculated as equivalent to 10 billion atomic bombs striking the planet's magnetic field. Scientists choose their language carefully here, and that careful language is itself the warning. When NOAA states that a Carrington-level event occurring today has the potential to cause widespread electrical disruptions, blackouts, and damage to the electrical power grid, that statement was written by people who have read the data and are, in the tradition of scientific communication, understating what they know, a Carrington-level event today would not simply cause disruptions, it would cascade. The grid is interconnected in ways that 1859 could not have imagined. The northeastern United States alone carries a transmission infrastructure serving a population larger than all of Canada, and the transformers at the heart of that infrastructure, the ones that step down voltage from 500,000 volts to something households can use, are not hardened against geomagnetically induced currents. Not most of them. Not yet. The 2025 PLOS One study is unambiguous. Examining geomagnetic storm data against Department of Energy outage records across 17 years, the researchers confirmed that the relationship between geomagnetic storm activity and power outages of unknown or unusual origin is real and documented. During the May 2024 G5 storm, the one that generated a KP of 9, a DST of -412 nanoteslas, and aurora visible from the Tropic of Capricorn in Australia, a 500 kilovolt transformer at the Salem Nuclear Generating Station in New Jersey failed under GIC stress, one transformer, one facility, in a G5 storm for which grid operators had advance warning and were actively monitoring. The study notes that peak neutral currents in Latin American power networks during that same May 2024 event exceeded 30 amperes at multiple substations in Mexico, measured simultaneously by the Mexican Space Weather Service. 30 amperes is not catastrophic on its own, but it is a data point, it is a measurement of what a G5 storm does to infrastructure thousands of kilometers from the storm's nominal impact zone. The question is not whether. The question is when, and the connected systems compound this. What the Met Office data for May 15 through 2026 shows is not simply one driver or two, it shows a coronal whole high-speed stream that, by the Met Office's own characterization, sustains solar wind at strong levels 600 to 730 kilometers per second for multiple days before the CME arrived. Co-rotating interaction regions, the compressed walls of interplanetary plasma that form at the boundary between fast and slow solar wind, are themselves capable of triggering G1 and G2 storms. They arrive predictably every 27 days, because the sun rotates every 27 days and an Earth-facing coronal hole returns to that same geometry 27 days later. This is not random. This is a structural feature of the solar system. And when a CME arrives on top of that already disturbed solar wind environment, when the fast-moving ejection catches the slower ambient wind and drives a forward shock through already elevated plasma density, the interaction intensifies the geomagnetic response. NOAA's CN-LIL solar wind prediction model exists precisely to forecast this interaction, to give utilities 1 to 4 days of advance warning of solar wind structures moving toward Earth. Think about what that warning window means for a family in Duluth, Minnesota, a city of approximately 91,000 people on the western tip of Lake Superior, at a latitude that places it squarely within the high-risk zone identified in the Lloyd's of London Grid Vulnerability Assessment. Duluth sits on bedrock, ancient granite, electrically resistant, the same rock shield geology that made Quebec so vulnerable in 1989. If a Carrington-class event were heading toward Earth right now, the CN-LIL model would give forecasters at NOAA's Space Weather Prediction Center in Boulder, Colorado, perhaps 18 to 24 hours of definitive warning after the CME was confirmed by the Discover spacecraft at the L1 Lagrange point, 1 million miles from Earth. 18 to 24 hours. That is the window, not for individuals. Not for families in Duluth to stock their pantries or fill their bathtubs with water or charge every battery they own. That is the window for utility operators to implement load-shedding procedures, reduce power flow on vulnerable lines, and manually disconnect transformers that cannot be hardened in time, and some of them will act. Hydro. Acted in 1989, the recalibrated systems they installed afterward held through subsequent storms. PGM, the regional transmission organization coordinating electricity flow across 13 U.S. states, explicitly stated after the May 2024 G5 event that they take geomagnetically induced currents very seriously now. The preparation is real, but preparation is not the same as hardening, and hardening is not the same as immunity. The system is not inactive, it is accumulating risk. Every year of delay on widespread transformer hardening, every budget cycle that passes without funding for neutral blockers and series compensation on the most vulnerable extra high voltage lines is a statistical increment in the probability that when the large event arrives, and in the context of solar cycle 25, which NOAA and NASA both confirm has been more active than initially predicted and is approaching, or at maximum the response will come 1 minute too late. There is a sunspot region on the far side of the sun right now that space weather forecasters are watching. Space.com reported it this week, confirmed a large active region currently rotating toward Earth-facing geometry that will come into view early next week. Forecasters noted it. They used the word fireworks. That is not hyperbole from a science website. That is a characterization grounded in the observation that an active region rotating from the solar far side onto the disk is an active region that has been producing flares and eruptions already on the side of the sun we cannot directly see, and is now bringing its history of activity into the half of the solar disk aimed at Earth's orbit. Minutes are not hours, and in this context, that difference is everything. The difference between a glancing blow that generates aurora alerts and an unsettled night and a full Earth-directed CME from a large active region at disk center is not primarily a matter of storm intensity. It is a matter of magnetic orientation. It is the difference between B's pointing north, the interplanetary magnetic field aligned in the same direction as Earth's own, deflecting the incoming plasma, and B's pointing south, where the two fields connect, where the magnetosphere opens, where the energy transfers and the currents begin to flow. That orientation cannot be predicted until the Discover spacecraft at L1 detects it approximately 15 to 60 minutes before impact. 15 minutes is not enough time to warm up a transformer, remove load from a vulnerable line, or call a grid operator in a facility 3 states away. The KP index that NOAA confirmed for the January 19 through 21, 2026 geomagnetic storm, a real documented event in the NASA Kimk-Donkey system, reached 867. That was 4 months ago. It was a G for storm. It was caused by a CME launched on January 18th. The KP values peaked at 833 and held above 7.0 for more than 12 hours. That storm caused aurora visible at middle latitudes and generated the warnings the relevant utilities received and responded to. It did not cause widespread blackouts because the response was prompt, and the interplanetary magnetic field orientation, while significantly southward, did not sustain the worst-case scenario for the full duration. But it is in the record now. 4 months before today, a G for storm, and in between, a G to storm in March 2026, also documented, also in the Donkey database. The storms are not becoming less frequent. The instruments are measuring what is happening in real time. Here is what the official data actually shows. May 20th, 2026. A CME glancing blow confirmed, solar wind at strong levels, KP elevated, G1 conditions possible through today, a large active region rotating onto the Earth-facing solar disk early next week. Solar cycle 25 at or near maximum, having already exceeded forecast intensity. A grid serving hundreds of millions of people in the northern hemisphere that contains transformers not hardened against GIC saturation, transmission lines that become antennas for ground-level electrical currents in a severe storm, and a forecast window that narrows to 15 minutes at the critical moment of magnetic orientation. Determination. And behind all of this, behind every instrument, every KP reading, every Discover measurement and GOES 19 coronagraph image, is the simple physical fact that the sun is not performing unusually. The sun is doing what the sun does. It is in a phase of elevated activity because it is near the maximum of an 11-year cycle, the same cycle that has run without interruption for as long as the geological record of solar activity exists. The nitrate and beryllium-10 layers in Antarctic ice cores preserve evidence of large solar particle events going back 9,000 years. The Carrington event of 1859 was not unique. It was not even the largest. Studies of those ice core records suggest that an event approximately 50% more intense than Carrington occurred around the year 775 AD, detectable in carbon-14 spikes in tree rings preserved across multiple continents. The scale of what the sun is capable of is not bounded by what we have measured with instruments since 1859. It is bounded by what the geological archive shows, and the archive shows larger. The world's power grid did not exist in 775 AD, it did not exist in 1859. It was young and small in 1989, when 6 million people in Quebec went dark at 2:44 in the morning and engineers spent the following hours manually restoring a system that had failed in 90 seconds. It is enormous now, physically enormous, a network of conductors stretching across continents, a system designed with extraordinary engineering discipline to deliver electricity reliably through every challenge the weather and the geography of Earth can produce, every challenge except one, the one that does not come from below. The one that does not come from the wind or the rain or the fault in the ground, the one that comes from 150 million kilometers away, moving at 650 kilometers per second, carrying inside it a magnetic field whose orientation will not be known until it is 15 minutes from arrival. The monitoring is in place and detection is possible, but prediction is not. And somewhere above the quiet dark of Duluth, above the sleeping streets of Burlington, above every city and town and hospital and water treatment plant connected to the high-voltage transmission network of the Northern Hemisphere, the solar wind is blowing at strong levels tonight, KP elevated, conditions unsettled. A coronal whole high-speed stream winding down, a CME's lingering effects fading, and on the far side of the sun rotating slowly, day by day, into Earth-facing geometry, a large active region that forecasters are watching with the particular attention they reserve for things that have not yet arrived. The sun has been doing this for 6 billion years. It will be doing it long after the last instrument on Earth has gone dark. The question it is asking right now, the question encoded in every photon that left its surface 8 minutes ago and is striking your skin as you read, this is not whether we understand it. It is whether the understanding arrived in time.